Alright, we just did number 11 on page 404. Let's go back and do number 7 and then number 9. Again, this is page 404. This is number 7. It reads, the claim, the mean time between uses of TV remote controls by males during commercials equals 5 seconds. The claim is that the mean equals 5 seconds. And the sample data, N, is equal to 80. X bar, we are told, is 5.25. Assume that sigma is known to be 2.5. And we're going to use a 0.01 significance level. So we start by writing the opposite of our claim. That's going to be mu does not equal 5. This is our null hypothesis. This is our alternative hypothesis. Again, since sigma is known, we're going to use z-test. So we pull up in our calculator, stat, test. Z-test is the first option. We're given the stats, so we should have stats highlighted. The value of the null hypothesis is 5. Sigma is 2.5. X bar 5.25. And N is 80. We should highlight the inequality that's in our alternative hypothesis, which is not equal to. Hit calculate, and we've got our test statistic and p-value. Z is 0.894. And the p-value is 0.371. So we're going to form our initial conclusion by comparing our p-value to the significance level. As you can see, the p-value is not less than the significance level, so we fail to reject the null hypothesis. Our formal conclusion: there is not sufficient evidence to, and we're going to write reject next because our original claim is the null hypothesis. Reject the claim that, just restate the claim, mu is equal to 5. Last, our critical value. It's a normal distribution, so we use inverse norm to find the critical value. Our critical values are in both tails, so we're going to enter half of alpha. 0.01 divided by 2. Plug that into our calculator. Second, vars, inverse norm, 0.01 divided by 2. And we get positive and negative 2.58. Alright, very good. On to number 9. Same page. Problem reads, in order to monitor the ecological health of the Florida Everglades, various measurements are recorded at different times. The bottom temperatures are recorded at the Garfield Bight Station, and the mean of 30.4 Celsius is obtained for 61 temperatures recorded on 61 different days. Assume sigma is 1.7. Test the claim that the population mean is greater than 30. Testing the claim that the population mean is greater than 30. Using a 0.05 significance level. We are told that the sample size is 61. The mean temperature on those days is 30.4. And sigma is known to be 1.7. Alright, so again, we're going to use z-test because the population standard deviation is known. Before we do that, the opposite of our original claim is going to be less than or equal to. Mu is less than or equal to 30. We're just going to write equals 30. This is our alternative hypothesis. This is our null hypothesis. So we go to z-test, hit stat, test. Z-test is the first option. We're going to enter the statistics. The value of the null hypothesis is 30. Sigma is 1.7. X bar 30.4. N is 61, and we should highlight greater than. Hit calculate, and we've got our test statistic and p-value. 1.84 is our test statistic. Our p-value is 0.0331. Alright, so now we can compare our p-value to the significance level. 0.0331 is less than 0.05, therefore we reject the null hypothesis. Our formal conclusion. There is sufficient evidence to, our original claim is the alternative hypothesis, so we'll write support the claim that, restate the original claim, mu is greater than 30. And lastly, state the find the critical value, inverse norm. Inverse norm, let's see here, our critical value is going to be in the right tail. So since it's in the right tail, we use 1 minus alpha. 1 minus 0.05 is 0.95. Let's plug that into our calculator. Second vars, inverse norm, 0.95. And we have 1.64 is our critical value. 1.64. Alright, very good. On to page 415. We're going to start with number 1, page 415. Alright, number 1, it says the claim is that mu equals 100, sample data n equals 15, the sample mean 102, s is 15.3. The sample data appear to come from a normally distributed population with unknown mu and sigma. So, because the sigma is unknown, we would use a t distribution for that one. The sample size is not greater than 30. However, the population is normally distributed. We would use a t distribution. Number 3, mu is equal to 980. That's the claim. Let's see. The sample standard deviation is given. Sample mean is given. It says the sample data appear to come from a normally distributed population. Therefore, the sample size is irrelevant. And sigma is known to be 30. Therefore, we'd use a normal distribution for number 3. Alright, on to number 17. It says, students of the author randomly selected 40 people and measured the accuracy of their wristwatches with positive errors representing watches that are ahead of the correct time, negative errors representing watches that are behind the correct time. The 40 values have a mean of 117.3 and a standard deviation of 185. Use a 0.01 significance level to test the claim that the population of all watches have a mean equal to 0. Alright, so this is number 17. Testing the claim that the watches have a mean equal to, mean equal to 0. So for number 17, we're using a significance level of 0.01, and it appears that the mean, well, the sample size is 40. There are 40 values. They have a mean of 117.3. Sample mean is 117.3, and a standard deviation, sample standard deviation of 185. 185. Again, if the population standard deviation is given, it will clearly say population standard deviation or sigma. So we do not know the population standard deviation, therefore we're going to use the t-test. Opposite of our original claim is mu does not equal 0. This is our null hypothesis. This is our alternative hypothesis. Pull out our calculator, stat, test. We want to go to t-test. And we're going to enter all the values given. The value of our null hypothesis for number 17 is 0. The sample mean is 117.3. Sample standard deviation is 185. Sample size is 40, and we want to highlight not equal to. Calculate. And we write down our test statistic and p-value. Test statistic is 4.10, 4.01 that is. And this is a t test statistic, 4.01, and our p-value is 2.67 times 10 to the negative 4. So we compare our p-value to the significance level. It is far less than the significance level, therefore we reject the null hypothesis. We write our formal conclusion. There is, since we are rejecting, sufficient evidence to, our original claim is the null hypothesis, so we next write reject the claim that, restate the original claim, mu equals 0. Then lastly is our critical value. In order to find a critical value for t distributions, we're going to use t interval. So we pull open our calculator, stat, test, t interval. There's 8 on my calculator. When I'm trying to find the t critical value, I'm going to enter 0 for the sample mean. For the sample standard deviation, the square root of the sample size, square root of 40. Sample size is 40. And then the confidence level, since the critical value is in both tails, I'm going to use 1 minus alpha. Alpha is 0.01, 1 minus 0.01 is 0.99. Hit calculate, and I'm going to have a positive and negative critical value. Positive and negative 2.70. Let's see, we use t interval. We got positive and negative 2.70. Very good.